In this Grasshopper tutorial, I will be modeling the Camboo Pavilion project, and as you can see here, we will be modeling this with a plugin called lunchbox. We talked about this in the last week and in the brainstorming idea, and if you just checked out the link, you can see that the Camboo Pavilion project is just basically a simple mathematical surface, which we will talk about this in this tutorial. So first of all, I want to explain about the base surface, which you can see here, and then use that base surface to model the pipes. But about the surface, which you can see in this project, in the Design Boom website, which I will also put the link to the website in the description bar, you can see that it says that the form takes on the mathematical Enneper surface. So basically what we need here is the Enneper surface, which I will show you how you can simply use the lunchbox plugin to produce that in Grasshopper. As you can see here, we have this. Let's just put the bifocals plugin here, the Enneper surface. So we can manage to have this surface and some of the famous mathematical surface in Grasshopper, but I have also a complete lesson in the Grasshopper course, so for those who want to know more about mathematical surfaces, they can go to the advanced tutorials, and in the mathematical surface we have about 40 minutes of how we can model the isomesh and parametric surfaces in Grasshopper by using different plugins, and so you can define the mathematical formula to produce the Enneper surface. But for this tutorial, which is a simple way to model the Camboo Pavilion, is to first of all install the lunchbox plugin, and here we have the lunchbox, and you can see that the lunchbox has a mathematical surface default here, which you can also use. You can also check out different plugins in the website food4rhino.com, which is a complete library of the Grasshopper plugins, which you can also download different mathematical surfaces. But for now, we have the Enneper surface here, which we can simply use that to produce the base surface. So what we want to do is to use that Enneper surface. Let's just go to the bifocals plugin. And you can see that there's a U and a V division. And what it means is that if I bake the surface, and let's just go to the shaded mode, you can see that this surface is defined by 50 U curves and 50 V curves. So the UV division will just define how many curves you need here. The second step is the R parameter, which you can change here by the numbers. We can say from 2 to maybe 12. And you can see if I give this a 2, you can see the first Enneper surface, which is 2 curves on this. So if I go to the 3 and 4 and up to whatever we want, so you can see that you can produce that surface to the base surface is, I think it's a 3, so you can see a parameter for the form is a 3 one. The scale is simply a scale for the complete project, so you can also scale this up and down. But I will also teach you how you can scale this in the height, length, and width of that. Okay, the domain 1 is from 0 to 1. So if I want to change this, I can go to the mathematics and choose the construct domain tool and make it from 0 to maybe 0.25, a number between 0 and 1, and you can see that this will start to make the surface based on a number between 0 and 1, which is the fundamental thing for the domain 1 and 2 for a parametric surface. So we can also change that if we want. So let's just put that to 1. You can also download this project from the website to change those numbers and see what happens. Okay, so the next one is the domain 2, and you can see that it's minus pi to plus pi, and we can simply again put a construct domain to that and start with a pi. And because it has something like minus pi, so assume that this is a complete pi, if we just say that it's that, and this is maybe something like a minus pi. So that is the domain which all the surface is just revolved. We can also change that by maybe saying from 0. I want to show you what happens if I say from 0 to maybe 1 pi. Okay, so you can see that we can change that from minus pi, and that is a complete half of that. So let's just give this a 2 pi, and you can see that there's a problem with this. So if you want to just go with the minus pi to pi, let's check this out. We can simply do this. Let's just delete that and give that to this. And I'm going to say minus x, because that will be minus pi to pi. Okay, and you can see here. And now we can just multiply that with a number between 0 and 1, and also control that. You can see. Okay, so maybe you want to use this part of it. So maybe if you just put that 0.5, you can see that you can just produce the half of that, and maybe just simply mirror this surface on the YZ plane, which is the default, I think. You can see that's a YZ plane, but let's just show you that the plane which we just used the mirror is the YZ plane, and you can see that we just produced a new surface which is not an Enneper surface but just a mirror. So let's just bake this, and you can see that we have produced another surface. So remember, you can, okay, let's just cancel this. Remember, you can also play with this, and you can see that how you can play with that surface. But if you change this, you can see that the mirror will just not produce the complete one. So remember, that has to be 0.5. So let's just delete this and go to 1. So this is the complete Enneper surface we want. We can also give this an R parameter, which we talked about this, which we can change the number of the patterns. Okay, so here we have the surface. One of the problems for this surface is that we can't control the height. Maybe we want to know how much the height is for this, and how much the width and the width of this and the length of this surface can be controlled after we just produce the surface. So this is the surface, and what we can do here is to use a scale non-uniform and scale this in the XY plane. So this is the default XY plane. I'll just show you here, and you can see that's the XY plane and that's the XY plane. So how much should we scale this? This is a technique you can use. Let's just give a simple box from the params menu. I can give this params and give this a box. So let's just connect the box to this. So this is the bounding box for this surface, and now we can just go to the surface, deconstruct brep, and let's just deconstruct this and take those edges. So I'm going to take those edges from the list item. We talked about this in the different Grasshopper tutorial. List item will just take off the index of that. So the 0 is the width of this, and 1, let's just zoom in. So this is 0, this is 1. I guess we need another number here, so I'm going to give this a 5, maybe to find okay, the edge which is in the height of that. Okay, so this is, okay, that doesn't really matter, 8 or 9. So what we want is this length, and the height of that. And what I'm going to do is to first go with the X direction, and that is exactly the scale in the X direction. Okay, so let's check out the length of this curve. We can simply connect a number to that, and I'm going to connect a number, and as you can see, this is 31. So the width of this is simply a 31, and assume that we want to make this something like a 50, right? How can we scale this in the scale X direction to reach a width of 50 meters? What we can do is simply, if I divide 50 to 31, then maybe something like 1, I don't know, 1.5 or something. And if we just found this number, so the number we want to reach, the length which the Enneper surface is now. We divide these two, we get a number, and now we can use this to give that to the scale x, and that will be scaled up to 1.5, something like that, and it will reach the 50. So the concept is really clear. Divide the length of that edge to the main number and then give it to the scale x, y, or z. So let's just do this. And what I'm going to do is to say the width is something like 50, 25. So let's go to the math and use division. Divide this to the main length, and you can see that it's 1.58. Okay, let's just give this to the scale x. So you can see that now, if I just put a bounding box to this and bake that, we have exactly 50.25 for the length of that surface. So this is the way you can control that mathematical surface which you don't know the height or the width or anything else. Okay, so let's just do this for the scale y. Again, we need that for this length, and this is the y direction, so I'm going to give this to the y, and so we can control the x, the y, and give this exact width and length, and then we can also copy this to the height. So this is the height divided by the number we want, and we just give this to the scale z. You can see that we can control that scale of the z direction, and maybe we just want to scale this to reach the results. Okay, so this is the technique you can use if you want to control that Enneper surface to reach exactly maybe 30 meters height. Okay, so from down to up it's 30 meters. Okay, so here we have the surface. So you can also work on the base surface, but I wanted to give you this tip so you can scale up those surfaces you don't know. So this is the base surface. Let's just give this to a surface and turn everything off. And let's go to here, and now what we need is to produce those pipes. And one of the things you can do, and the main lesson for this tutorial, is to go to the curve and spline and use the spline for curve on surface, excuse me, isocurve. So isocurve is basically the U curves or the V curves. Okay, we want to extract that so we can just control that for the pipes. And you can also learn from the isocurve section. So let's just give this to the surface. And if we want to extract U or V direction, this is the technique. First of all, if you have a surface, reparameterize that so the domain is from 0 to 1. Then, as you can see here, this is a UV point. For those who don't know what a UV point is, you can also watch the evaluate surface tutorial and check it out. I will also put this at the end of this video, or you can also check it out at the description bar. If you check out the evaluate surface tutorial, you can understand what a UV coordinate is. So be sure to check that out. And what we need here, if I give this an MD slider, let's just make this a smaller one, and if I give this, you can see that I can control the U and V curve. So this is basically the U curve. You can see that I can change that U curve, and this is the V curve. So if I just go up and down, you can see that I'm starting from 0 going to 1. This is the V curve, and if I go from 0, you can see I can start from 0 to 1. So this is the thing we need, and you can simply produce that by going to the vector and the point and construct point. We need to make a point here. This is the technique you can always use to use the isocurve, and then give this to the UV point. For the sake of learning this tip, I'm going to give this x coordinate a U, and the y coordinate the v, and the z coordinate we don't need a z coordinate. Okay, so I'm just going to put that simple nothing, and let's just give this 0.25, so you can see that I can control the u, and then we can control the v. Okay, and now what I'm going to do is to make this one of those 0, so you can see v is 0, but use u so for something like this: 0, 0.1, 0.2, 0.3, and up to the end. So this is the technique you can use. We go for a range. A range is simply default is 0 to 1, and this is the steps we need, so maybe we need 12 of them. So you can see we can simply divide 0 to 1 to 12 sections, and then we can give this to the u. Okay, you can see that we can produce that u curves, and we can also change that. If you want to also change the distribution of this, this is a really cool tip you can use, and that is to let's just turn this off and use a graph mapper. So if I use a graph mapper, I can change the distribution. Let's go for the Bezier distribution. You can see that I can change this distribution. This is really great and cool. You can see that I can change the distribution from at the ends to the near of that starting of the U-curve. And this is also another thing you can use, but remember, if you go for the sine or something like that, that will just bring those curves up and down. That will go to the end, come to the start, and so we don't need something like that, remember? So you can also change that. I'm going to put that for a none, and then we can also copy this, and this time I'm going to give this, instead of a U, to a V. And here we go, we have this V curves, and here it is. But because of this surface, you can see that those pipes are on each other. We can simply dismiss this V1, and let's just pipe the U curves. I guess that's the V curves. Okay, so this is the V curves because the U just was one of those. Let's just give this a radius, maybe 0.25. Okay, here we have this. Okay, because of this radius is 0.25, we have to offset this surface exactly at that for that. Okay, let me just explain this on this drawing in canvas. Assume that this is the pipe, okay, and I can just draw this with the mouse cursor, but that's not really bad. Okay, but assume that another curve is coming here and it wants to sit on that other pipe. So let's just draw this. So if we have a surface offset by 2 of that r, or radius, that's the diameter of that pipe, you can also make that 2 pipes almost tangent at the intersection. So let's just go here and use the offset surface, offset the base surface. I don't know if it goes up and down. Let's just check this out. Let's give this 2 times of this radius. So I'm going to go to the mathematics, 2 times, and let's just give this to the distance, and it goes down. So if you want to put the pipe at the down section, you can use that. You can also go for the expression -x if you want to put the surface outwards. Okay, here we go, and now we can use that technique for the isocurve again, and now we will give this to the offset surface. Remember, you have to reparameterize the surface, and you have to give this to the V point because we want the next direction. Let's just increase that, and you can see that this is on the offset surface. Here it goes, and then we can just give this another pipe. So let's just give this to the U curves, and here we go. You can see that this will just sit on that. Let's just bake this to prove it. I'm going to give this to the layer 1 and bake this into layer 2, and here we go. You can see that this is sitting on that simply, but maybe there's a problem for here at the end. You can also make this a little bit, okay, let's just go to Grasshopper. For the intersection of those curves at the end, you can go for the U-curve and use the subcurve. Okay, the subcurve will make the curve smaller, so let's just do this. We also talked about this in the structural frame space frame tutorial, so we can also again reparameterize that and start from a domain. So the domain is from 0 to 1. If I give this a 0 to 0.2, you can see that it starts from here. So this is 0 and it goes back to the 1. So 0 to 1, we can say maybe we want 0.2 to 1, right? So we can start from there, and you can see that you can change that. And here we go, we can give this one to the pipe. So remember, you can also change the length of those pipes, and you can see that they are intersecting. Maybe we just give this 0.15 and make this better. Okay, this sits on that, so maybe let's just 0.13. So it just sits on that little pipe here, and we can also delete that first pipe to end the project. Okay, so this is the layer 1 of those pipes, and this is in the layer 2, and we can also delete this, and here we go. You can see that they are sitting on each other, and we have them. We can also just make this a little bit smaller to prove that they are sitting on each other. Okay, so this is the structure of that, and you can see that it's really similar to the Camboo project. So there are for sure there are tips for making this in the real world, but there are details, but you can see this is really similar. So this is the way you can make it, but for in the Grasshopper section, we can see that this is not really hard to model in Grasshopper. Okay, we can delete that, and let's just choose from the display a custom preview to just color those pipes, turn everything off, and let's just give a swatch, because I just want to give this another color, maybe a blue, and a swatch for this, and maybe change that to another color. Okay, so you can understand the two different pipes here. And then we have the panels. This is just a little bit of a tip of using lunchbox. So what I'm going to do is to go to the offset. So let's just find this. This is the offset surface, and again, let's offset this outwards. So again, we have to offset this time again 2 times the radius, and because this is inwards, I'm going to give this a -x, and just wait for that. Okay, let's just give this a -x, so it just goes outwards, and we have the surface on the pipe, and then we can just produce panels on that, so we can have them in the lunchbox. I'm just waiting for this to be finished. Okay, and here we go, another offset. You can see here we have another offset. So this was the first surface, the second, and the third offset, and now we can go to the lunchbox, and maybe we just give this a simple quad panels. You can use those panels. Let's just change this to the UV division, maybe 20, and let's just change this. Okay, I think that has to be an even number, so let's just give this an even number here. We can increase that, and you can simply give that panel. Okay, make this a little smaller. If you want to be it just exactly as the pipes, we can use those numbers. You can see that we used the 14. Let's just give this the 14 and the 47. And you can see that they are sitting exactly on those pipes if you just want to show them. And instead of quad panels, you can also use the isotrim. For those who have worked with Grasshopper, they know that you can also use the isotrim tool to produce the smooth surface, but assume that they are panels. And then we can also scale them a little bit, but that's not I don't want to show that in this tutorial because this is the base thing we wanted to produce in Grasshopper, and you can see those are the panels. And let's just go and produce the pipes and layer 1 and layer 2, and we're good to go. Okay, and we can also maybe put this in the layer 3 and layer 4. I want to give this a material so you can see that. Okay, let's go to layer 1 and give this a simple blue material and transparency. It's not really important, but I want to give you the sense of the surface, and you can see that this is the simple results. We can also delete those panels at the end if we want to. Again, this one, and okay, let's just shape this. We can also delete this layer. We don't need that one, and we are good to go. So we have this in different layers. You can give this to Keyshot or use it in different rendering software, something like 3D Studio Max or so on. So this is the tutorial for producing the Camboo Pavilion, and thank you for watching and subscribe to our channel.